Okay, good morning and afternoon. Welcome and thank you for joining today's public consultation webinar. We're presenting the methodology M-ICR020, a methodology focused on electrification and low emission technologies in commercial applications, developed in collaboration with Triveni, Earth Movers, and Ecoveta. The goal of this session is to walk through the methodology and gather your feedback as stakeholders. So ICR regularly hosts consultations and webinars and workshops as part of our commitment to transparency and open methodology development. You can find all of our events, both past and upcoming, at carbonregistry.com/events, where you can also register for future sessions and access recordings. Public consultation is a key step in our process before any methodology moves to validation and approval. So your participation today directly shapes the findings. For this agenda, we are going to go over the ICR methodology approval process, where Gummi is going to take you through all of its processes, the program and the public consultation process. Then Tritip is going to go over the methodology overview of the M-ICR020 methodology. And finally, we're going to have a Q&A session in the end of this webinar. And for the Q&A, you can, throughout the whole webinar, you can add questions. If you go to the lower right corner, the bottom right corner, you can see dots there, an icon where you can add Q&A, and we will try to answer them as possible. So just briefly going over the speakers, I see here Guðmundur Sigbergsson, CEO of ICR. He leads its carbon crediting program and methodology approval process with a focus on climate policy, carbon markets, and sustainability. Work centers on developing carbon accounting systems aligned with standards like ISO 14064 and strengthening credibility through robust methodologies, validation, and stakeholder engagement. And now, Gummi, if you introduce your fellow speakers.
Thank you for this turn, for this introduction. And welcome all to this webinar session for the introduction of the M-20 methodology. So with me here, with us here today is Mr. A.J. Campbell. A.J. Campbell is a sustainability professional at Lloyd's Metals and Energy and Triveni, Earth Movers and Infra, where he manages sustainability assurance systems aligned with GRI standards. He has experience in corporate responsibility, compliance frameworks, and transparent reporting. A.J. holds a management degree and is certified in CSRD fundamentals. Based in Mumbai, he works on strengthening ESG frameworks and improving accountability in the energy and metals sector. Also with us and doing the main presentation is Mr. Tritip Gogoi. Tritip Gogoi is a climate and sustainability professional at Ecoveta, focusing on carbon markets, GHG accounting, and project implementation. He has experience developing carbon projects in areas such as clean cooking, renewable energy, and waste to energy. His work includes baseline assessment, additionally monitoring and emission reduction calculation with a focus on implementation and alignment with international standards. Myself, I will be going through the methodology approval process, but the methodology approval process inform how new methodologies in the carbon markets are included in the ICR methodology library. A little bit about ICR, who we are, and our history. So we are a GHG program and a carbon registry, the infrastructure as such. With us, we have about over 200 projects. There are about 10 plus methodologies, somewhere in development and validation in public consultation. So as of now, there are 4 methodologies in the public consultation process, and in the coming days and weeks, we are presenting 2 additional methodologies through a webinar session. We're working with over 25 VVPs. There are over 230 project developers that we work with, and we have then connectivity through different marketplaces and resellers of the output of all the projects that are registered with us. In addition to that, we also on the technical side or the software side, we have multiple features that support the delivery of both the carbon credits and also how like the narrative of each project is delivered to all the stakeholders that are involved in the carbon markets. So go into the methodology approval process. So methodologies, we have always been welcome to new ideas, new innovation in the climate space, and that is one of the reasons why we were established in 2020. It was to support climate innovation ideas and how to scale into approved methodologies as they adhere to ISO 14064-2, which is the fundamental standard in climate project development. The ICR requirements that inform the carbon markets expectations, they are subject to validation by an approved VVP. They are subject to public consultation and stakeholder engagement, where we are today, and we are still in the public consultation period, and then subject to ICR review and final approval. So what informs the methodology approval process? It's the fundamental criteria for all project that needs to adhere to. That is the ISO 14064, which brings the fundamentals of project development, which delivers the requirements for describing the project activities, the sources, sinks, and reservoirs, the baseline scenario, the boundary of each project, the qualification, monitoring, etc. And then, in addition to that, the missing carbon markets elements, this is safeguards and SDGs, additionality, permanence, double counting crediting, and so on and so forth. For project to adhere to the fundamental criteria are methodologies, and we have different pathways for project to align with the criteria. And there we have the approved methodologies that are mainly in our CDM legacy methodologies, and now transitioning into the PACM, the ICR methodologies, where we are today. Then other methodologies that are informed from other GST programs, and then finally establishment of criteria and procedures within the project documentation. So essentially developing the process or the methodologies within the projects. All this is then governed by the principles of carbon markets, which is relevance, completeness, consistency, accuracy, transparency, and conservativeness. About the documentation that is relevant to the methodology development, there we have this in different pillars. Different pillars. We have the requirements that you will find in the ICR methodology requirements that tells you what needs to be included in the methodology. Then, of course, the ISO 14064-2, and then terms and conditions. Then we have the procedures, which is outlined in the methodology approval process. To support, we have the ICR definitions, and then finally the templates, the amazing Word templates that we work with, which in our concept note, methodologies description, and validation, of course, validation reports for methodologies. So, what is a methodology? So, a methodology outlines the criteria and procedures on how to measure and calculate GHG emission reduction, removals, enhancement for a specific activities or product. It defines the approach to determine the baseline monitoring emissions and report on GHG impacts, ensures that the process is systematic, reproducible, and verifiable, and essentially application of constant consistency throughout any project activities, so they can be compared between different project activities. They normally just include the scope of the scope and applicability of the set activities, any normative references such as which methodologies are inform the development, then definitions that are relevant to the methodology or the process activities, and then the normal sections about the baseline, the quantification, monitoring, etc. But they always need to result in real GHG emission mitigations. In the methodology requirements, you would see usual suspects, and the methodology are aligned to the ISO 14064-2 standard structure, where you have the scope, the normative references, definitions, principles that governs the methodologies, general requirements, and then the methodology components, which are, of course, the other methodologies that inform development, summary descriptions of the activities, definitions, applicability conditions, boundary, baseline, scenario, additionality, quantification, and monitoring. One feature that is important for the final approval is the implementation of a project, either a mock-up or dummy project that shows how the methodology is developed. Methodology is applied at the project level to identify any missing gaps during the approval or the validation. And then we have this requirements relating to how the methodology needs to be validated. Then the template essentially just copies or aligns with the structure of the requirements, and you would also find instructions on what it is that we are looking for in each section transparently. So how does a methodology flow through this process? So this starts with a submission of a concept note, which currently is optional. We provide our feedback to that concept note if we see that it's robust enough to proceed into a full-on methodology, and also identifying any gaps that developers need to consider during methodology development. Then we prescribe, of course, the validation and the public consultation. We have we have allowed public consultation to be completed prior to validation, which we are doing now. So the public consultation and the comments that we are receiving through the public consultation will be delivered to the VVB when the VVB is conducting the validation of the methodology. Then we have the ICR review, which like is more of a consistency and completeness review that then funnels into the final approval of the methodology. So, and below you see then the project development process that the developers of the methodology need to see or show how the methodology has been applied at the project level and informs a final registration of a project that is applying that methodology. Through the M-ICR020 methodology, so we started the work with Triveni and Ecovita in July when we got the submission of a concept note, where we reviewed that concept note, provided the developers with our feedback in September. From September through January, March, developers, Ecovita and Triveni, worked on the methodology considering the feedback from our review. They also have submitted a draft PDD that Mr. AJ will tell you about later, and then responded to any comments that we shared in the review report in March. Now we are in the public consultation that is extending from April 2nd through May 2nd. And we encourage all attendees and other stakeholders to participate in the public consultation, because it's important to get stakeholder feedback, so we don't miss anything out in the approval or in the development of the methodology. So, as said, the public consultation is ongoing, and if you scan this QR code, you should be taken to the public consultation page, and you will find the form for sharing your comments under the public consultation page. So with further ado, I want to welcome Triti to share his slide deck. So Triti, please go ahead with your presentation, and thank you for joining this webinar.
Thank you. Let me share my screen.
And just while we wait, I saw that someone raised their hand during the presentation. Not sure if that was by accident, but if you have something to say or ask, please use the Q&A functionality and add questions to which we will then answer in the presentation. Thank you.
Okay, so good morning, good afternoon, and good evening, everyone presented here from the different parts of this globe. Today, we will be presenting the methodology introduction of low-emission electric hybrid vehicles and mobile machinery in commercial applications. This methodology has been developed under ICR framework to quantify GHG emission reductions achieved through the transition from conventional fossil fuel-based vehicles and mobile machinery to lower emission technologies. The methodology applies to electric vehicles, hybrid vehicles, dual fuel vehicles, and also includes mobile machinery such as equipment used in mining, construction, and logistics, and material handling operations. In addition to new deployment, the methodology also covers and allows retrofitting of existing vehicles, machineries, where high GHG intensive fuels are replaced with low GHG emitting alternatives. The key objective of this methodology is to establish standardized and conservative and technically robust framework for quantifying emission reductions across sectors that are currently underrepresented in other standards and carbon methodologies. These sectors include mining, construction, and logistics, which are significant contributors to GHG emissions due to their high dependence on fossil fuels. So moving towards the methodology overview. So the core concept of this methodology is the transition of high GHG emitting vehicles and mobile machinery to lower GHG emitting technologies, which are more cleaner than the previous ones. These transitions can take place through the replacement of the existing technologies or retrofitting of the existing equipments and systems, also allowing switching of fuels or deployment of new technologies. This methodology has been developed by Tiveni Earth Movers and Infra Private Limited in collaboration with Ecoveda Climate, and it focuses specially on GHG. It focuses on GHG emission reduction. A key strength of this methodology is that it addresses a critical gap in existing methodologies. The current methodologies which are available largely focuses on road transport systems and do not adequately cover non-road mobile machineries and dual fuel applications. This methodology provides a unified framework that includes vehicle also, mobile machineries also, and multiple type of fuel also under a single structure, and thereby enabling a broader applications across industrial sectors. So the methodology is applicable under clearly defined conditions to ensure consistency and environmental integrity. The project must involve replacement or retrofitting of high GHG emitting vehicles or mobile machinery with lower emission alternatives. It also covers a wide range of applications, including passenger transport vehicles, freight vehicles, and industrial machinery such as dumpers, excavators, loaders, drills, and logistic support equipments. The methodology is globally applicable in commercial deployment scenarios. So one of the most important conditions is that the project must maintain the same level of service as the baseline. This means that the distance traveled during the baseline, the operational output, and overall activity level, that should remain unchanged. And there should be no model shift. So this ensures that the emission reductions are not achieved by reducing activity, the operational activity doesn't change, but by improving the technological efficiency and fuel use. In case of hydrogen use, the methodology requires that the hydrogen must be produced using the renewable electricity from a dedicated renewable energy sources. So another critical condition is that baseline equipments must not be at the end of operational life. So this is to ensure that the project represents an entirely transition, and not a necessary replacement cycle. It is not like that they have to replace their older vehicles, then they are purchasing the newer technology. It is not like that. They have to abandon their technology, their traditional technologies before their end of life. So another critical condition is that all replaced components must be disposed of through certified recycling facilities to ensure that no environmental leakage occurs due to the improper disposals. So moving towards the baseline scenario. So in this methodology, the baseline is defined as the continued use of fossil fuel-based vehicles and mobile machineries without any transition to cleaner technologies. This means that there is no fuel switching, no technological upgrades, and no improvement in operational efficiency. And all operations continue using the traditional fossil fuel-based systems. Now, if you look at the diagram on the left side, then you can see that the primary source in the baseline scenario is the fossil fuel. This represents that the energy sources used in the baseline scenario are emitting a good amount of GHG gases. So moving towards the center of the diagram, you can see that the existing vehicles and mobile machineries, these are conventional equipments such as dumpers, excavators, and loaders, and other machinery operating entirely on fossil fuels. So in the right side, you can see that the operations lead to carbon dioxide emissions being released into the atmosphere. So what this diagram is showing is a very direct relationship where fossil fuel is consumed, it powers equipments, and this results in GHG emissions. If you observe the entire flow left to right, it is a single linear pathway with no intervention or improvement in efficiency. So this diagram clearly represents the business as usual scenario where emissions are directly linked to fossil fuel consumption, and this serves as the reference point for calculating the baseline scenarios. So moving towards the project scenario. So in this project scenario, the high GHG emitting vehicles, mobile machineries are replaced or retrofitted with electric, hybrid, or dual fuel technologies. So key point is that the level of service remains the same, but the emissions are reduced due to the improved technologies and cleaner energy sources. So now if you look at the diagram again, so in the left side, you can see that the input is not limited to the fossil fuel. So here electricity used as a symbol representing the cleaner energy sources. So moving to the center of the diagram, you can see the project vehicles, mobile machineries. So this represents electric equipment, hybrid systems, or dual fuel machineries that operate using lower GHG emitting energy sources. So you will still see the carbon dioxide emissions, but a key difference is that these emissions are significantly reduced compared to the baseline. If you compare this diagram with the previous one, you will notice that the pathway is no longer purely fossil fuel based. Instead, the energy input is diversified and partially shifted to the lower emission sources. This clearly shows that while same operational activity continues, the emissions associated with the operational activity are reduced due to the adoption of cleaner technologies. So, uh, so this diagram demonstrates that the project achieves emission reductions not by reducing the operational activity, but by improving the energy source and efficiency of the system. So the key parameters that are fixed at the validation stage and how their values are determined within the methodology. The first important parameter is the specific fuel consumption of baseline vehicles or mobile machinery. So this represents the amount of fuel consumed per unit of service, which is measured as the kilometer uh, as the fuel per kilometer for vehicles and fuel per operating hours for mobile machinery. This parameter is fundamental in determining the baseline emission intensity. The methodology provides multiple approaches for determining the value to ensure both flexibility and conservativeness. The preferred approach is direct sample measurement, where the actual fuel consumption data is collected from a representative sample of baseline equipments operating under comparable conditions. So the sample must satisfy the statistical requirement of a 90% confidence interval and plus minus 10% of precisions. The lower bound of the confidence interval is selected in this methodology to ensure that the conservative is reliable. So if direct measurement is not feasible, the methodology also allows the user to use the manufacturer data from the top 20% most efficient vehicles in the market, which ensures the baseline are not overestimated. Alternatively, historical operational data from similar equipments can be used in cases where sales data are not available. So control group data or published statistics can be used with conservative values selected. The second parameter is the physical leakage of hydrogen, which represents the percentage of hydrogen lost during the storage, transportation, and handling during the operational activity. This parameter is either taken as a conservative value and project based. So the third parameter is the global warming potential of hydrogen, which converts the hydrogen leakage into carbon dioxide equivalent emissions. So this value is derived from IPCC guidance and is treated as a constant during the crediting period. These parameters are established at the validation stage and remain fixed or conservatively defined to ensure consistency, transparency, and reliability in emission reduction calculations. So moving towards the next slide, the important parameters to be monitored during the project activity. So these parameters are essential because they are used to calculate the baseline emissions, project emissions, and the net emission reductions. The first parameter is the service units, which represents the activity level of the project. This is measured as the distance for vehicles and operating hours for mobile machineries. This data is typically monitored continuously and aggregated annually, ensuring that the project maintains the same level of service as the baseline. Also the important parameter is that the number of operational vehicles or machinery is also monitored annually based on the actual deployment and operational status, as it directly affects emission calculations. So this number also have to be defined during the project activity. So then moving towards the next parameter, the net calorific value of fuel represents the energy content of the fuel and is obtained from the country specific or IPCC default values. This parameter is generally constant unless the fuel type is changed. So electricity consumption is continuously also have to be monitored during the project activity using meters at charging points and is aggregated annually. So this parameter is needed to use to calculate the emissions associated with the electricity use. This is also an important parameter to calculate the project emissions. So the next is that the electricity emissions factor represents the emission intensity of the grid and is updated periodically based on the national data. It also depends on which types of electricity sources the project owner is using. But they depend on that applying the proper tool, you have to calculate the electricity emission factors. So the next parameter is the fuel consumption of project equipment is also monitored also needed to monitor continuously, especially for hybrid and dual fuel systems using fuel records or the flow meter systems or whatever is available at the project sites. So the next factor is the emission factor of fuel that is derived need to be derived from the standard data sources. If the project is using biofuel, then both the quantity and blending ratio of the biofuel need to be monitored, and only the portion of blending that is exceeding the regulatory requirement of the host country is considered as eligible for quantification of project emissions and this net reduction emission reduction. So hydrogen consumption is also as allowed in this methodology. This also need to be monitored continuously and need to be aggregated annually for project emissions calculation and leakage emission calculations. So all these monitored parameters are used to calculate baseline emissions, project emissions, and leakage emissions and emission reduction to calculate as a difference. So the net emission reductions is calculated as the difference between the baseline emissions and the project emissions after accounting for the leakage. So this is how we are getting the net emission reduction. So moving towards the next slide. So additionality framework. So this is additionality is to ensure that the emission reductions are real, measurable, and it is beyond the business as usual scenario. So this is totally designed following the guideline provided by the ICR, that follows the level 5 additionality, which is defining the latest additionality specification documents. So according to the ICR guidelines, the level 1, level 2, and level 3 additionality analysis is obligatory, and level 4 and level 5 is optional. So project developer need to analyze the level 1, level 2, and level 3 for the particular projects. So following the ICR guideline, this methodology also follows the structured multi-level additionality framework. So the first level is the baseline additionality, which ensures that the project reduces emissions compared to the baseline scenario. The second level is regulatory additionality. So where the project must go beyond legal requirements or operate in a context where regulations are not enforced. The third level of additionality is that addresses barriers and common practices requiring that the project overcomes financial, technological, or institutional barriers and is not widely adopted in the regions. So that this is a technological barrier or institutional barrier. So project developers is working in a different way to procure the technology to their project areas. So the fourth level of additionality is addresses financial additionality, where project either has a higher cost or have a lower higher value, depends on the carbon revenue for the project feasibility and viability. So fifth level is the policy additionality, where the project goes beyond national climate commitment. So this is all about the additionality framework. So and moving towards the next slide, the project overview. So I would like to hand over this slide to Mr. Ajay Kamble to describe about the project. So Mr. Ajay.
Yeah. Thank you, Pradeep. Thank you, Pradeep. Thank you, ICR team, for inviting us on this call. Am I audible?
Yeah, you are audible. Please go ahead.
Okay, thank you. So basically, this heavy equipment, which we call HEML, these are majorly mining equipment all over the world. These are big size equipment, and we are trying to transition into electric or battery operated vehicles. This transition, the conversion of this equipment, this we are doing in-house with the help of OEMs. And so far we have converted around. We have tried to convert around 20 equipment, 15 to 20 equipment, and at present almost 10 to 15 battery operated trucks, 70 tonners are operating in our mine. Yeah, that's a good point.
Okay. Thank you, Ajay. So basically, this methodology provides a comprehensive and unified framework for quantifying the emission reductions from transition to low emission vehicles and mobile machineries. So it addresses the gap in the existing methodologies and covers a wide range of sectors and ensures conservative and robust emission accounting. So it supports industrial decarbonization and enables large-scale deployment of low-emission technologies while maintaining credibility and transparency in emission reductions calculation. So this is all about the methodology. Thank you all.
Thank you for this informative presentation. Now, as I mentioned, we're going to go step into the Q&A session. We had prepared some questions before, but also if you have some questions you would like to ask, please don't hesitate to add them to the Q&A, or even the chat. We'll try to look at both. But beginning with the first question here, can you explain how existing methodological approaches have informed this methodology where it departs from those approaches, and how it ensures that mobile machinery applications are not already sufficiently covered under existing methodologies?
So the existing methodologies such as AMS-3C and AMS-3S have been used as a foundational reference for this methodology when we are developing it, particularly for emission quantifications, logics, baseline determination, and monitoring structure. However, these methodologies are limited to on-road passenger and freight transport and do not extend to non-road mobile machinery or dual fuel systems. So if I talk about the AMS-3S methodology, it is limited to commercial vehicle fleets only. It doesn't cover the mobile machineries. If I talk about the AMS-3C, then it covers only the electric and hybrid vehicles, restricted to passenger and freight transport, exclude mobile machineries. So it doesn't allow that dual fuel system also. So if we go to the revised methodology, that is under BERA, so BMR 0014. So it covers mobile machinery, but limited to electric and hybrid only. So dual fuel system is not allowed. So when we are going through the different methodologies, so the new methodology covers the combined scope of vehicles, mobile machineries, dual fuel, hydrogen, biofuel, also allowed retrofitting of the existing technologies. So fragmented approaches require multiple methodologies. So that's why we're developing this new methodology, so that it introduces a unified, comprehensive framework, covers all relevant technologies and sectors, and it enables the project developer so that they can develop a single project accounting across the diversified equipment types, and reduces complexity and increases scalability and adoption in real-world industrial applications.
Thank you for that. I see that we just got another question. Where does the methodology see room for technology partners, MRV platforms, telematics, battery as a service, charging infra, retro kits, etc.?
So in part of the monitoring plan, so how we are quantifying the emissions, so the methodology establishes a structured monitoring framework covering all key parameters, so including the service units, the energy consumption, the fuel use, the emission factors. So data is continuously collected. So such through metering system for electricity and fuel consumption is and is also aggregated over the period and for annually. So as defined in the monitoring table. So consistency is ensured through different stages like use of standardized data sources, defined monitoring parameters, and clear boundary conditions. So changes in performance over time and such as equipment aging, battery degradations are inherently captured through annual monitoring of actual energy consumption and service output. So we are not going through the we are like going to measure the actual energy consumption, like how much the fuel the PD is accounting for the operations, then how much output of service the vehicles and mobile machineries are giving. So this all ensures that the actual amount of energy and energy consumption and output is used for quantification of project emissions. So this ensures that monitoring is plan is good enough for conservativeness.
Brilliant, thank you.
Thank you.
Did you have some questions?
Yes, just a little bit curious about the baseline logic, and that relates also into like additionality of the application of the methodology. as electrification trends, regulatory policies, improvements in the sector is evolving rapidly in different regions, and yeah. So how does the methodology ensure that the baseline scenario remains valid and conservative over the entire crediting period, especially in regions where electrification of such test technologies is already been adopted at scale?
So in this methodology, to ensure the conservativeness over the time, so the methodology incorporates multiple safeguards. So first is that the use of conservative baseline parameters, such as the lower bound fuel parameters, fuel consumption values, and the top 20% efficiency benchmark where applicable, to ensure that baseline emissions are not overestimated. So in the second, a technology improvement factor is also applied annually to reflect the gradual efficiency improvements in baseline technologies, which effectively reduces the baseline emissions over time. So additionally, the parameters such as key emission factors, the project performance are monitored periodically and updated using the latest available data sources and whatever the operational data available. So this ensures that the emission calculation reflects the real world conditions. So together, these measures address the risk of overcrediting by ensuring that the baseline remains conservative and responsive to the evolving conditions.
Thank you. Also a little bit curious about, like, also we're transitioning into the PACAM era. There were like methodologies need to adapt to, like, what do you call it, the constant lowering of the baseline. Have you considered submitting this methodology under the PACAM under the PACAM rules to the supervisory body?
So you are asking that are we going to register this methodology under PACM? Am I right?
Yeah.
So currently we are not thinking about that. Currently we are registering this methodology under ICR framework only. So we have also projects which are already in pilot phases. So we have submitted the dummy PDD along with the methodology description to ICR. So we are selected ICR for its conservative baseline setting, robust additionality assessment, and clear monitoring and verification requirements. So also that ICR allows flexibility to develop methodologies addressing the sectoral gaps, so which are not adequately covered in other standards also. So ICR also follows the ISO 14064 set of standards. So it ensures that the carbon credit generated through the ICR is transparent and it has integrity enough to the market. So we are currently going for ICR only.
Thank you for the kind words. A little bit about like on leakage, because like I know you covered this under your presentation, but you have some safeguards in the methodology. So like for the end of life of the baseline machinery. So can you tell us a little bit how you're dealing with leakage in this methodology?
So in this methodology, currently we are identifying the leakage primarily in relation to hydrogen, where upstream emissions from hydrogen productions, handling, transport are explicitly accounted for before using established tools. For displacement of baseline equipment, the methodology includes safeguards such as requirements for proper disposal and certified recycling in retrofitting scenarios, which reduces the likelihood of uncontrolled redeployment. So in addition, the project boundary conditions requires clear tracking of project equipments, so ensuring that the emission reductions are attributed only to the defined assets. So indirect effects such as electricity consumptions are already captured through the application of grid emission factors in project emissions calculations, so which inherently accounts for the carbon intensity of electricity use. So where the potential leakage sources are identified as material during project implementation, conservative assumptions or exclusion can be applied to ensure environmental integrity.
Thank you for that. So given the nature of that, the emission reduction from the electrification from fuel switching, so do we see any like specific users or buyers of the credits that are stemming out of the project that are applying this methodology?
So credits generated under this methodology are expected to be relevant for organizations seeking to address emissions within their value chains. So the primary buyers include industrial companies, supply chain partners, corporate with decarbonization targets. So the credits generated in this methodology related to the value chain decarbonization. So given that the industrial natures of the operational activities and project activities, these credits are particularly aligned with the hard-to-abate sector. So any player from the hard-to-abate sector, if interested, they can purchase these credits.
Thank you. Now we have a new question in the chat or in the Q&A. Regarding the multiple baseline selection, it may lead to risk of selecting a biased baseline. How do we know that options must be chosen in which situation, and how to prevent choosing the most beneficial one?
So in the baseline, there are 5 options to select the specific fuel consumption. So the primary option is to select the operational data, the real data which are available with the project developer. So if not, we are ensured that they select a conservative value, like the value from the top 20%, top 20% efficient technologies, so that the baseline emission is minimum. So it is conservative enough. So we are selecting the upper bound in the baseline scenario. So this is how we are designing that. It has to be a conservative way to calculate and quantify the ER.
All right. So I have one final question from my side. We have gathered some feedback through the public consultation. We saw some comments, but it highlights concerns about the baseline assumption, leakage, and monitoring robustness. How do you intend to consider the feedback from the stakeholder consultation in the methodology development?
Yeah. So stakeholder feedback from public consultation is an important part of methodology development process. So in this process, the key concerns such as baseline conservativeness, leakage, and monitoring robustness are being addressed through the parameter definitions, enhancing the monitoring requirements, so incorporating the additional safeguards, so wherever it is necessary. So the methodology is designed to be iterative, and feedback is used to redefine the assumptions. So input way it can improve the clarity and ensures that the final version meets both the technical and environmental integrity expectations. So through this webinar, we would like to strongly encourage all the participants to carefully go through the draft methodologies in detail and share their valuable feedbacks to the official consultation channels, so that we can incorporate that we can incorporate that feedback to our methodology. So whenever we are submitting the final methodology descriptions, so we can, whenever possible, whenever it is a way to improve our methodology, we can do that. So your value, everyone participating here, we are encouraging you to submit your feedbacks, and your feedback is very valuable to us and to improve our integrity.
Thank you. And I want to echo that. We really would like all the participants here and those who are watching this webinar after the session to participate in the public consultation, and you will find all the information that's needed under the ICR documentation page. You can find it easily also on our registry platform and LinkedIn and wherever.
Yeah.
So I don't think we have any more questions, Björn.
Yes, yeah, this is just, and we're almost on time. So just thank you everyone for participating and showing up for this webinar. Thank you, Guðmundur, and thank you especially to Deep and AJ from Ecoveta and Triveni. A recording of the webinar will be sent out after this webinar, obviously, and then maybe when does the official public consultation end? What's the date for that?
2nd of May.
2nd of May. So please, if you have something you want to submit, don't hesitate to do that. Yes, but thank you everyone and have a nice day.
Thank you all. Thank you for your time.
Thank you all. Bye-bye.
Bye-bye.